Lesson 4.3, using congruent triangles. Rather than teach this, I'm going to let you figure it out. So I want you to pause this in a moment and write down everything you know if we also know that they bisect each other. I'd like you to pause it and write down everything you know based on that statement. Anything else that you can read into the diagram. Now I will do it. Hopefully you've paused it and tried it yourself because I think it would be a healthy thing. A, B, and CD bisect each other. A, B, C, D. So this is congruent to this, and this is congruent to that. I also know from vertical angles that. So now I want to write a proof. That's all the data I know, and I got to go write the proof. So set up your proof. And again, I would pause the recording and see if you can do it yourself. So I'm going to do the proof now. See if you guys can figure this out. Your given is that A, B, and C, D bisect each other. At M. So based on that, you know that AM is congruent to BM and DM is congruent to CM. And that would be definition of a bisector. If you put something else down, as long as it's got the general idea, that's totally fine. Then I would say, and I just give them numbers, make my life easy, angle 1 is congruent to angle 2, and that's by vertical angles. Then I would say triangle, and I gotta be careful, AMD is congruent to triangle BMC, and that is by side angle side. And the last step, so we want to know that AD is congruent to BC. We would say that AD should be a little, they are up there, congruent to CB by CPCTC. Once we've proved the triangle is congruent, corresponding parts of congruent triangles are also congruent. So, zoom out so we can see things here. What else can you say about this segment AD and this segment BC? Well, now that we know CPCTC, we could say that these two angles are congruent. And then we could say that AD is parallel to BC, and that would be by alternate interior angles, technically the converse, but you don't have to write that down. Just say alternate interior angles. That's a classic proof, and it's also classic geometry. Take something you got the hang of, and bang, we immediately make it much more complex. So remember, you're always looking to get triangles congruent first. Then you can look at CPCTC for whatever the problem itself is asking for. Not too bad once you dig deep into it. Good luck.